Hey everybody, this is Alex Merced from alexmercedcoder.com and devnursery.com, where you can find all my videos all nice and categorized. Um, and what I want to do is in this next video about Rust, I want to talk about strings, because strings are a little strange in Rust. Okay, there's kind of two ways to work with them. Okay, first I could just do something like this. I could do let my string. Okay, and then I have to type it, which would be an ampersand str. Okay, and that's just a straight up like string type. And usually you would use this if you already know what string you're going to attach. So if I'm going to put in like hello world here, that would be sort of the way I'd probably want to do it. Okay, and this is not like a string object, it's just a pointer to a string variable in memory. So it's just a string. And then I could print it out. So I could just be like print f. And again, we need to use exclamation point because the printf is actually a macro built into Rust. So we say printf, and then we're going to say quotation marks, and then we put these curly brackets as a placeholder. And then after that words, we specify the variable we want to fill in that placeholder, which is my string. Okay, and then that should print hello world. Okay, a macro with similar name exists. Or is it print? Print. Or is it print f? No. You see what the error says. Help convert the identifier to snake case. Help convert the identifier to snake case. Oh, that's right. Rust doesn't like camel case. It forces me to use snake case. Okay, well, I fixed that. Oh, that's right. I didn't change it over here. String. And if you're wondering why I don't edit out when I make mistakes in the video, one, I want you guys to see that I make mistakes so you see how I solve them. Two, I don't want you guys to think I'm some omnipotent programmer. And I do think the extra time that it takes for you guys to see me fix my own mistakes is as valuable learning as watching me do the thing. Because we see the errors, we see the solutions to the errors. It's a valuable exercise. To me, the getting it wrong is just as important as getting it right. It's just as educational. So that's why I kind of do that in these videos. It's also easier for me. I don't have to do as much editing, but there is, I do think, a value in you guys watching the raw process as when I do coding stuff. Okay, let's run that again. And it works. See, hello world. Okay, so again, that's using this type. Okay, now another way we could do a string. So let's get rid of up to here. Okay, we'll just say let my string equal, and then there's a string object in, it's not really an object because Rust doesn't have classes. Okay, so there are objects, but the way it handles object orientation is a little bit weird. We'll get into that in the future. But basically we do string from in this case, and if we do string from, then we can put in the string hello world, and this would be find 2. Okay, just put my semicolon over here, and this should be work. String from, yep, that, and see that works as well. Okay, what this does is it just takes this string and turns it into a string object, and the string object has all these other sort of methods you can use to do all sorts of really cool stuff. Then one more way to show you. So let me get rid of all of this. Now for this, you're going to want your variable to be mutable, so we have to add let mute my string, and then we create a new string object that's blank. That's why it needs to be mutable, so we can update it. New, and then we can, okay, do this. My string dot push string, and then here we can push in hello world, and if I remember right, that should work. Let's see, there's an associated function with similar name. Oh, push stir, that's right. Everything's always abbreviated in Rust. Cool, and then so you get hello world. Okay. And I do really like the errors in Rust. They're actually really good about making suggestions about how to fix it. So that I'm really liking about the compiler, that it's really good at telling me sort of this is the remedy. It is interesting kind of assuming immutability and then having to opt into mutability. That's sort of a difference. Instead of usually it's the opposite, where variables are mutable and then you have to take some sort of action to make them constant. So that's an interesting design choice that I can see the value in. Cool. Otherwise, let's take a look at like some basic stuff like ifs and loops. So all this is pretty straightforward. The only difference is that you don't have that 3-part for loop, and then also like Go, you don't need parentheses for your expression. So it'd be like if true, print it's true, else print it's false. Okay, and yeah, let's try that out. So right now it's true, so it should run it's true, and it does. Now let's change this to false, and again you can put whatever expression there. Just think of it like any other if statement you've done in any language. And again, if you don't know a programming language yet, this should not be your first. You should go back, watch my JavaScript videos, my Python videos, my Ruby videos. That's usually a better place to kind of get your start and build up from there. And then move on to like my Go, C, C++, Java, in this case, Rust videos. Okay, because it's a process to learn all the ideas and concepts. Cool. So that works the same as it generally does in any language. Then there's the while loop. So let's declare a variable. So we'll just say let x, and then we'll say x is, well, actually I'll just make it dynamic because I'm just gonna, but okay, I could just be like I32. Actually, I think I can even do like I8. So an integer, an 8-bit integer equals 0. Because this number's not going to get that large, so I don't need a very big. And that's the benefit of these I8, I8, I16, I32, I64. It allows you to specify when you really need the extra memory space. So it doesn't give you the maximum, it doesn't take up the max amount of memory space that is needed for an integer. Because if you know it's going to be a small number, why not take the least amount of space? And I think I might be even able to go lower than this, but I8's fine. Okay. So again, that just means an integer of 8 bits. Okay. So let's see here. And then we're going to say while x is less than 10. Then we create the loop. So again, no parentheses around the expression. Oh, I just felt the bird just clamp onto my chest. So if you hear a bird, that's my bird. Just flew on my shoulder. So while x is less than 10, what we're going to do is print. And that would be, again, we just have to do the whole interpolation thing. So that's the placeholder. That's the variable we want to print in that placeholder. And we need a semicolon at the end of that statement. Okay, compiled languages always love those semicolons. Except Go. I don't think Go I have to do semicolons. I have to go revisit Go. Print, and then we also want to make sure that x goes up. I'm not 100% sure we have the increment operator here, but I'm going to go with it. X++. I'd be surprised if it isn't there. So x++, and so that should loop so many times. Yep, according to degree there. Expected expression. Got it. I guess it doesn't have the operator. So let's see here. Does it at least have this? Plus equals 1? That would make life a little easier if that works. Let's see here. Cannot assign twice to mutable. Oh, that's right. They're not by default mutable. So we do that. Make it mutable. See? Very nice errors. Okay? Very clearly what I did wrong. And see there, it puts them all in the one line. So if I want to get them on separate lines to make that clear, I just put in a new character or new line symbol. And there you go, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It loops. Now the other kind of loop it has is a for loop. I think it's a for of loop. I always forget if it's like for in or for of. So it's all those different ones. But let's first make an array. So let's see here. Let x, or let's say let y equal See, well, let me just do this. 1, 2, 3, 4, 5. That'd be nice if it does. Let's get rid of this loop. And for num of y, print and then a new line y, and let's hope that all works. This should also have a semicolon, and I'm not seeing any errors at the moment, so that's encouraging. Okie dokie. Now let's run the compiler. Nope. For num of y. Try placing this code instead. For num of. Interesting. Okay, it's saying that I should do this. That I should put the y in a curly bracket. So for num, Control Z. For num of y, like that. That's what it's suggesting. Okay, so let's see if that works. Nope, I think that makes it worse. Okay, so let me go double check the syntax for this, the for of loop. Let's go back to Rust, let's go back to loops. Alright, where's the for loop? For num in 0. Okay, well there they're using a range, so I guess I'll use a range. Okay. Give me an example with an array. No, they don't. They don't give you further examples for x and 1. Oh, that's other stuff. So let's see here. First, let's try it with a range, so between 0 and 11. And what is that like? Not like kill preference the code inside of a block. I don't see why I need to do that. For x 11, that's pretty much what I'm doing. Oh, it's in, not of. So yeah, I told you. I wasn't sure if it was in or of. Okay, so let's go back and try the y again. Okay, so for num in y. Still, let's see what it's not like. Cannot be formatted with the default formatter. Oh, because that's right, because that's the array. I need to interpolate the value, which is num. There we go. Nope, let's see here. For num and y, borrow the array with at or call dot iter to iterate over it. Okay, so this is actually an interesting error, because this goes at a deeper sort of feature in Rust called borrowing and ownership. The idea is that not more than one thing can be referring to the same value. So I can't have, even if it's the same piece of information in memory, I can't have x and y point to the same piece of data. So in this case, y, which is the array, it has to give up ownership of the reference for the period of the loop. So this way there's not two things referring to it. And I think the benefit of this for Rust is that it helps it do garbage cleaning when you decide to do memory cleanup. And again, that's one of the benefits of Rust. It kind of tries to find this in-between between sort of completely manual memory management a la C, C#, C++, and versus like garbage collection of like a C#, JavaScript, Ruby, those languages which do garbage cleanup automatically and sacrifice performance for it. So in this case, what they're doing is they're saying, okay, well, we want to make sure that, references to variables exist as long as they are necessary. We only want sort of one connection to that variable, so we know exactly sort of what your program needs right now, so that way we don't clean up anything you don't want to clean up when the time comes, and it's easier to clean it up because you don't have multiple references to the same variables or to the same data. Okay, so in that case, I have to kind of give it up. And here they show me two ways I can do so. Okay, I can do so by putting an ampersand next to the y, which just basically says, hey, I'm passing the reference to it, so I'm giving up ownership of this memory address to this for loop until the for loop completes, at which case y will take back ownership. Okay, which it didn't. Oh no, actually that worked. See, there you go. You see the loop right there. Okay, there is a warning. Let's see what the warning says. Variable does not need to be mutable. Oh, okay, so it's just complaining about this since I didn't use it. So just get rid of that. Yep, and then that worked. Okay. Now the other option it gave us was, other than using the ampersand, was to use .iter, which allows it to be iterated over. So let's see how that goes. It does the same thing, and so you can see here for some reason the other characters are all disappearing, but it's working. Okay, so you have those two choices, those ways to kind of get around this whole ownership issue in Rust. Okay, so that was actually a pretty good example, pretty good use case of why that matters. Cool. So yeah, you've learned that there's for loops, and there's ifs, and there's while loops, and again, the for loops are for in loops, not for of loops like other languages, and or any of the other permutations of, you know, loops of those iterable loops that we see in other languages. And then we now know, now you have been introduced to the whole idea of ownership and borrowing. So again, ownership just means only one variable, one sort of symbol can reference a particular spot in memory at a time. So whenever you enter functions or blocks of code in which you want to pass on that reference, you have to give up ownership. You have to let that function, that block of code, borrow ownership. Okay, and that's one of the concepts that's sort of like is sort of unique to Rust. I haven't seen that in other languages, at least not in that. I've seen references and pointers and stuff like that, but in this whole sort of like, there has to be a unique reference that's pretty interesting. So my name is Alex Brissett from alexbrissettcoder.com. Have a great day and enjoy.